Okay, this video is about simplifying rational expressions. So if we look at number one, we have x minus 7 divided by 7 minus x. I'm going to go through this once in a lot of detail to show you how to handle something like this. These are almost the same expression, but not quite. You can cancel them, but what's going to come out is not 1, but negative 1. So here's just a few examples for us to look at. What if I have something like x plus 3 divided by 3 plus x, or x minus 2 divided by 2 minus x. What is the difference in these two expressions? Right here, x plus 3 divided by 3 plus x. When everybody's positive, it's the same exact expression. You can rewrite this into x plus 3 over x plus 3. This will cancel and you'll get a positive 1 every time. When you have something like this is not the same. I could rewrite this into x minus 2 over negative x plus 2. These are equivalent. That is not exactly the same, but what we can do, I'm going to copy this down, x minus 2 over negative x plus 2 is factor out a negative 1, either from the numerator or the denominator. I'm going to choose to factor it out from the denominator. X minus 2, factor out a negative 1, leaving me with a positive x and a negative 2. So let's just make sure we agree with that. Negative 1 times x is negative x. Negative 1 times negative 2 is positive 2. So this is equal. And now we see that we have an x minus 2 over an x minus 2. We have a 1 over a negative 1. So what comes out is a negative 1. Once you've appreciated that and you understand what's going on there, then from now on, after you're like, okay, yes, I agree with that, that makes sense to me. When I come across something like this, x minus 7 over 7 minus x, I just know I could do the same exercise. What's going to come out of here is a negative 1. Right here, 2, y minus 9 over 9 minus y. These are close, but not exact. What's going to come out of this is a negative 1. Let's factor this. We have 49 minus y squared over y minus 7. We need to factor the numerator. This is difference of squares. You're not allowed just to switch it in your mind to y squared minus 49. Lots of students do that, but you can't just do that. We have to start with what's leading because the negative makes a difference. So this is a squared minus b squared. So it's going to be 7 plus y times 7 minus y if we factor that, divided by y minus 7. What I see here is that these are close but not exact. This is another one of these situations. So this will cancel, but a negative 1 will come out. So my final answer is going to be negative 7 plus y or negative 7 minus y. And then it would be over 1. So this is either one of these is my final answer. Okay, let's look at 4. How would we handle that? Let me make just a little more space on the board since we talked about that. How you can do this, let me tell you what I see a lot of students do, which is not okay. They'll see some expression like this, and let's just say here, oh, they're like, oh, I see an x here. This x can go into this x. Or I see a 12 here. I could divide this by 2 and this by 2. You're not allowed to just pick something and divide by it, just some little term by itself. You can only divide like that when it's factored. That's why right here what I had to do, I'm not allowed to say, oh, 7 will go into 49. Because if I see a plus or a minus sign, that's not okay, that's not legal. When everybody's multiplied, see, this is a factor times a factor divided by a factor. If a whole factor can be canceled, then that's okay. But if you just have like, you see a plus or a minus sign, it's not factored. So like right here, these are two terms being subtracted. These are two terms being subtracted. I'm not allowed to cancel anything unless I factor it first. So let's factor it first. Look at the numerator. What can I factor out? The greatest common factor that I see there is 11x squared. I could take a whole 11x squared out, leaving me with a 1 minus, and when you factor something out like that, it's like you've divided it. 22x cubed divided by 11x squared would leave me with a 2x. 1 minus 2x is what I'm left with. In the denominator, how can I factor that? Again, a greatest common factor. I'll factor out 6 times x leaving me with a 1 minus 2x. Okay, now that it's factored, now if I see something in common, I can divide it out. 1 minus 2x divides into 1 minus 2x one time. That works. Everybody is being multiplied, so if I see something here, this x can divide out with one of those x's. I'm left with 11x divided by 6 right there. That's the simplest, the form I can put that in. All right, let's look at 5. We have x cubed plus 8 over x plus 2. What students love to do, which is not right, is take this x and divide into that x cubed. Not okay, because I see these are being added, not multiplied. You have to factor this first. X cubed plus 8 is sum of cubes, if you remember this. A cubed plus b cubed factors into a plus b times a squared minus ab plus b squared. This is called the sum of cubes. This is the sum of cubes because this is, you can think of this as x cubed plus 2 cubed over x plus 2. And then I can say, oh, this is, in this case, a would be x and b would be 2. So my numerator, I guess I'm going to remove these parentheses, that's a little much. My numerator would be a plus b, x plus 2, times a squared, x squared, minus a times b, minus 2x, plus b squared plus 4, all over x plus 2. Now that it's factored, I can cancel. These will cancel out and give me a 1, leaving me with just x squared minus 2x plus 4. That's the simplest form that 5 can be simplified to. 6, again, this is difference of cubes. If we look at this, we have a cubed, x cubed, plus b cubed. 64 is the same thing as 4 to the third power, 4 cubed. So I could say this will factor into, if you think of it like this, it's this same factorization. This will factor into a plus b, x plus 4 times a squared minus a times b minus 4x plus b squared plus 16 all over x plus 4. These will cancel now that it's factored. This is a 1, leaving me with x squared minus 4x plus 16. So we get there.